So I hope you're buckled in. We're going to try and cram as many case studies as Natasha mentioned earlier. They're really, really useful to get people on board with what is actually achievable and what is being carried out across the industry. And Sean and I are going to try and take you through as many as possible. So as already said, my name is Claire Young. I'm based in London in the UK. Sean, I don't know if you wanted to say a few words.
Yeah, so I'm Sean Augustino, and I'm based here in a rainy, warm Washington, D.C. I'm involved with the American Society of Civil Engineers in their Circular Economy Working Group, so I'll be bringing a bit of a North American perspective as well, similar to Emily.
Excellent. So as I said, we're going to go through as many as we can in 15 minutes, which is quite a lot. So we're going to keep the introduction short and sweet. I thought I'd start with this slide saying that in 2020, for the first time in human history, human-made products outweighed the total mass of all life on Earth. Which is a pretty intense fact to be faced with and leads you directly into use less stuff so we don't propagate this into the future. Obviously, these triangles have been done to death so far over the presentations before us, which is great because it lets us move into the case studies quite quickly. Circular economy has lots of different definitions depending on what industry you're in. And so what we've tried to do is focus a few different examples here from the UK Green Building Council, the RIBA, and the London Plan, all their different metrics, and pulled them out into these 7 ones you see on the right-hand side. And we're going to be rating our case studies based on these metrics on the right-hand side. So that's what we will be focusing on. And they'll sort of come up for each project. I just popped my email address here if you want to screen grab it. What I would also say is get a notepad ready, get a screen grabbing tool ready, because we're going to go through these really quickly. But if you have any questions about them and you want more detail, just put that in the Q&A and we'll try and address it later. So first, I'm going to focus on the UK and Europe before I hand over to Sean, who's going to do the rest of the world. No small task. And I thought I'd start with the very top of the pyramid, do nothing. Some of you might have heard of Lacation Vassal, who won a very prestigious architectural prize recently because their principles as a practice are to do as little as possible. And in this particular case, they did nothing. They were employed by the client to establish how to rejuvenate or change or update this residential square in Bordeaux in France. And they assessed it and they said, this square is serving its purpose beautifully. It doesn't need any changes. Please just maintain it nicely and you'll be grand. So great option of questioning the brief here and eventually not doing anything. Next, we have Here East, which is most of you should be aware of the 2012 Olympic Games, which were held in London. This is one of the buildings that was constructed at that time to host the Games. So you can see on the bottom left there, the former press and broadcast centre. And this was adapted by Buro Happold and Hawkins Brown into a space that can be used for local businesses and innovators, and is designed as a very flexible and adaptable space and a long-term space. They expect this building to be here as long as possible, basically, and for it to adapt to the needs of the community during that time. And obviously, it's also a retrofit of a building that was constructed, albeit quite a young building. Next, we have the Water Tower, which is a lovely project completed a few years ago in Northern England. The client purchased the water tower that you can see in that top photo and was converting it into residential use. And the engineering team and architectural team did their utmost to use as much of the tower as efficiently as they possibly could, add as little as necessary to convert it into a residential state, and also to use very low impact materials during that construction. So there's a cantilever timber staircase, which is very cool. They kept the water tower tank at the top and cut a slit in it and got the window frames to act as moment frames to keep the shape stable, and tried to, essentially design all of the elements as efficiently as humanly possible. Then we have the Royal College of Gynecologists, which is in London, and is again another great example of really questioning the brief. So I'll skip to the next slide, where we have the building, the pink and the blue building are the original buildings on the site, and there was actually a consented scheme for a concrete frame on the site, and the team questioned whether this was necessary. Could we not adapt the existing buildings, leave them where they were, cover over the courtyard so that the difference in floor levels could be adapted through a staircase in the new courtyard. And they also questioned the building controls requirements for a live load of 5 kilonewtons per meter squared. In the top of this building here, which was being converted into a sort of office meeting space. And they managed to get that requirement down to 4 kilonewtons per meter squared based on the fact that for fire escape reasons, you couldn't even put that many people up on that floor. Next, we have Feldbølle School, which is in Denmark. A really lovely project designed to be very flexible and adaptable. It can be deconstructed by hand, so it can be relocated elsewhere if necessary, or just so that elements can be repaired. And then the materials used throughout are sort of wooden cassettes with straw bale, compressed straw insulation. They use seagrass in the filters, so the ventilation. And yeah, it's designed essentially for that sort of very flexible space as well, so it can be rearranged and adapted in the future if needed. This is actually one of Civic Engineers' projects in London, 318 Oxford Street. Some of you might be aware of the sort of House of Fraser. It's a 1920s, sorry, there's a typo there, frame in central London, steel frame building. And this is a great example of the collaboration that we've just been talking about and having these open conversations. So in this project, they're removing the top floor of the building and building new 3 stories up. And we've audited the steelwork that's in those upper floors that's being demolished, and where we couldn't reuse it within the building ourselves, we have done that a little bit. 2.5 tons are being refabricated and reused in the existing building. But conversations were had with a completely different design team, completely different client on a project elsewhere in London, and 20 tons of steelwork have been bought by that project and relocated across London. And that's, you know, that they weren't sent to a stockist and then bought separately by that project. That was had through open collaborative conversations between the clients and the engineers on the project, which is very exciting. It can be done. Also to point out that this is pre-1970s steel, and this was still justifiable. Next, we have the ABBA Arena, which is in London for now. So some of you might have heard of the this arena space, which is hosting the avatars, so a virtual ABBA concert. And this building has been designed to be fully deconstructable, adapts to any future locations where the tour might relocate to, and also designed very efficiently. So according to Xylotech, who are the timber specialist engineers on the job, they revised the original scheme for the auditorium, increasing the amount of engineered wood and removing about 140 tons of steel, and thereby halving the carbon footprint of the design. So really interrogating what was needed. Also, it's a really lightweight building. It currently rests on about 300 jack pads. So it's on a car park site. Got jack pads on it and then the frame. And when the arena is eventually deconstructed, that car park will remain intact and be able to reuse. And the building could be dismantled and sent somewhere else and re-erected. And lastly, we have this really wonderful project in Switzerland, the Kopfbauhalle, which was completed a couple of years ago, where they tried to bake in sort of proof of concept as many circular economy principles as possible. So they salvaged most of the new frames. There's an existing building underneath, and then there's a new steel frame above. That new frame, the skeleton was once a distribution center somewhere else in Switzerland for a shop, and that's been dismantled and brought to site and reused here and adapted. There's also a staircase, which you can see in this photo over here, which was again taken from a different building. Then all the cladding and the windows were salvaged from an office building in Zurich, the Orion building, which was due to be dismantled, and they salvaged all of these items and reused them in their project. And where they couldn't salvage materials and incorporate them, they tried to use as low impact materials as possible. So there's a lot of timber, straw insulation, and lime in the rest of the building. And they claim 500 tons of primary material were saved compared to if this had just been constructed out of new building components. So I'm now going to hand you over to Sean, who's going to talk about some projects elsewhere in the world.
I'm, as Claire said, going to focus on kind of The rest of the world, primarily with a focus on North America, since that's obviously my familiarity, but we'll tour around a little bit. So running through. So the first one is the MEC store in Ottawa, Canada. MEC is the big outdoor retailer across Canada. And in 2000, they wanted a new store in a different part of town in Ottawa. And there was actually a whole lot of reuse that happened here. There was an existing one-story Asian grocery on the site, and a lot of that got reused. Actually, a good chunk of the structural steel got reused into the new store that was being built on the site. In addition, the old MEC store in a different part of town was mostly reused in other locations. And then in the 2000 building was actually designed for flexibility and adaptability and disassembly. And in 2012, when they wanted to expand, they were actually able to do so and reuse 85% of the building. There was an estimate here that the initial construction of this cost 13% more than a traditional building, but it was estimated that that was probably quickly recaptured, especially with the expansion having to do very little additional work. The next one is the Quay Quarter Tower in Sydney. This is one that Arup was involved with. BG&E was the structural engineer, and this was the reuse and expansion of an existing tower. You can see on the upper left kind of what the site was. The tower is in red, and on the right is what it became. And there's a nice little graphic down there at the bottom indicating the kind of demolition in the red, and then the structure that was maintained, and the expansion in the green, which added probably about double or doubled the floor area. They were able to maintain about 2/3 of these existing structure and maintain about 12 or eliminate about 12,000 tons of carbon emissions relative to had this been torn down and built new. And in addition, there was also a lot of technical effort that went into monitoring differential shrinkage when adding the new concrete onto an existing concrete tower. And very quickly, there's a nice time lapse here that is worth seeing of how this all went up. And so you can see kind of the scaffolding and taking down all the structure that couldn't be reused, leaving most of that core intact, and then rebuilding that new floor plate around it. And there we go. And then moving on next in the Middle East in Qatar for the World Cup, Stadium 974, which was one of the host venues. This was done by Schlaich Bergermann out of Germany. And they actually designed this to be demountable and able to be reassembled in another location, either in the kind of current iteration of the stadium as it is, or in smaller multiple stadia. And 974 is named for the number of shipping containers that were used, as you can see here, for kind of a lot of the vending modules and stairways and such. There were some studies done on this that indicated that it's only really going to be a carbon benefit if this does in fact get reused on another site, especially now that the World Cup has happened. And so that's something that'll be interesting to keep an eye on if this really does get used for its intended design purpose. So moving back to the States, over to California. This is on the site of a former Army base on the California coast called Fort Ord, which we'll talk a little bit more about on the next slide. But one of the pieces of that base that was used was developed into a school, which was completed in 2006. And this one I love because there were kind of several things that went into this. They actually designed all of the timbers on a certain spacing, so pretty much everything was aligned on a 60 centimeter spacing. So it removed a lot of redundant framing and headers and such. Kind of made everything line up. They did some other detailing tricks too, which ended up reducing the framing that was needed by 30%. They made a lot of these trusses standardized. They made the mechanical connections demountable. So a lot of this was designed for disassembly. This is in California, high seismic, and the shear walls were actually over designed so that they could put various panels in or various openings in later if needed. And a lot of the utility systems are kind of exposed and separate from the structure, so those can be redone or changed without demolition needed, and the students can also learn about them. And there was a lot that went into documentation on this and training of the building staff so that as time goes on, this actually can be used and modified as was intended in the design, and that knowledge gets transferred. And then zooming out, talking about that whole base itself, this was actually part of a much wider reuse project by the United States Army. There was a group set up called the Fort Ord Reuse Authority, which was in charge of decommissioning the base, cleaning up the base, getting it ready for various forms of development. And a lot of that involved taking down the old housing, a lot of which was no longer tenable for various reasons. And there was about $5 million of research that went into how to do this, how to reuse as much as possible. About 400,000 square meters of building got deconstructed rather than demolished. And excuse me, one of the great things that came out of this was they developed this mobile lead paint removal trailer. Where, as you can see in the upper left, boards went in with contaminated lead paint on them. They got chipped off, and all that dust was contained in the trailer. And then out the other side, you get these nice clean boards that are able to be resold and reused. And they also developed this 4-tier hierarchy on reuse, which you can see here. So kind of, what was their first priority, and then going down, and finally, recycling is the last option if nothing else was possible. And then jumping to Africa, this one was the Rwanda Institute for Conservation Agriculture, which is a large new campus development there, just finished in the last couple of years. And this is to teach Rwandan students about conservation agriculture so that they can come kind of be the future of land management in the country and help manage the land in a more sustainable way. This focused on less than kind of those hard definitions of circular economy that were in those older slides, but more focused on natural materials, biodegradable materials, and such. But there were also, some other key ideas in here too of designing for flexibility and adaptability. A lot of the buildings were done on regular, like 4-meter by 8-meter grids, which allowed for repurposing down the road if needed. A lot of the trusses were standardized so that if one needed to be replaced, it was easier to be replaced, or if they need to be reused somewhere else, it was easy to do that. And a lot of the benefit there was also ease of construction, ease of labor training. And so, there wasn't this huge learning curve for the workers to be able to install it, but it was a lot quicker to get up to speed. And again, a lot of mechanical connections for easy demountability. And finishes were minimized as well to kind of keep the material down to a minimum. And again, a lot of earth-based materials, stone for the foundations, which you can see there, terracotta and timber for the roofs, earth for the walls. One lesson that was learned here is some of these products did need treatments that make them not necessarily biodegradable. Maybe the timber, making it either weatherproof or pestproof or whatever. And so that's kind of an area of research that's needed with some of these materials, is how to get those performance out without these, extra processes that make them harder to kind of go back to the earth at end of life. And then finally, back to the US in Seattle, the Bullitt Center, which was the first office building in the world to be certified under the Living Building Challenge, which had been briefly mentioned earlier. Living Building Challenge is kind of known as one of the most stringent rating systems that's out there right now. And what's cool about this building is that the structure was designed to have a 250-year life cycle. So really, or design life, so really focusing on longevity there. And then also the existing building that was on site, the 1-story building, which you can see on the upper left there, was all deconstructed by hand. And one thing we wanted to note is that we touched on a lot of great projects here. We hit a lot of different parts of the world, but there's a whole lot of great work out there that we were not able to touch on. And in particular, in developing nations, there's been a lot of circular design work that may not necessarily be, in fancy design literature today, but has been going on for a long time. And so we just wanted to highlight some of those. We can see a traditional bridge in India on the left, and a more modern architecture home design in Ecuador on the right. And so we just wanted to highlight how much great work is out there beyond what we can get to today.